Okay, so you want to run your own artificial intelligence locally.
Really?
Yes, master.
You want to disconnect from big tech subscriptions, bypass content filters, and own a private intelligence engine sitting on your desk. You download an open weight model, install a slick local client, and prepare
Goodbye.
to wave goodbye to cloud API bills forever. You think you just acquired free software. You didn't. Nobody does. You actually signed a high voltage lease on a physical hardware pipeline that turns household electricity into memory bandwidth. You did not eliminate operational costs. You traded a predictable pay-as-you-go software bill for upfront capital decay and a baseline utility charge. The question isn't whether open source models are free. The weights are free. The question is what it actually costs to manufacture a single token inside your own living room, who captures the margin, and at what exact workload volume local hardware stops being a wildly irrational luxury. By looking at the raw physics of silicon, memory bandwidth, ledgers, and electricity rates, we can calculate the exact point where local AI makes financial sense, and why most people building home server nodes are paying a massive premium for an illusion. To understand the money, you have to separate the software from the engine. An open weight model like Meta's Llama or DeepSeek is simply a massive collection of floating point numbers stored in a file. Downloading a 70 billion parameter model costs nothing beyond your internet bill. But executing that model requires holding every single one of those parameters in blazing fast memory simultaneously. In standard 16-bit precision, a 70 billion parameter model requires 140 gigabytes of video RAM just to load into memory before you ask it a single question. If you squeeze those numbers down using 4-bit quantization, you still need roughly 40 gigabytes of VRAM. That immediately creates a severe gatekeeping mechanism. Your standard consumer laptop does not have 40 gigabytes of dedicated video memory. Your everyday desktop gaming rig does not either. This is where the bill arrives, and it arrives in stages. Stage 1 is the capital outlay. To get 48 gigabytes of fast VRAM on a traditional PC setup, you can't just buy one consumer graphics card. You usually need two top-tier NVIDIA RTX 4090S or an enterprise workstation GPU. That is an initial investment of roughly $4,500 to $6,000 just for the computational core, motherboard, power supply, and cooling. Alternatively, you look at Apple's unified memory architecture and buy a top-spec Mac Studio with 128 gigabytes of shared memory for around $4,000. Either way, you are writing a 4-figure check before a single word appears on your screen. Stage 2 is the hidden utility drag. An enterprise dual GPU rig running full inference pulls around 800 watts from the wall. If you run that system under load continuously in a city with average electricity rates of 16 cents per kilowatt hour, wall power alone runs roughly $92 a month. In Western Europe, where power can hit 35 cents per kilowatt hour, that monthly utility charge rises to over $200. You are now paying a fixed monthly utility overhead equivalent to 10 separate premium cloud AI subscriptions, whether you generate 1 million tokens or zero. Now let's look at the cloud alternative. Cloud API providers operate on massive multi-tenant clusters. They buy enterprise hardware at bulk discounts, stack thousands of requests per second, and achieve GPU capacity utilization rates exceeding 80%. Because of those hyperscale efficiencies, API prices for mid-tier open weight models dropped dramatically, sitting around 30 cents per million input and output tokens. Let's run the ledger. Suppose you spent $5,000 on a dedicated home AI rig to avoid paying cloud API fees. At 30 cents per million tokens, how many tokens do you need to process just to recoup your $5,000 hardware purchase? 16.6 billion tokens. To grasp what 16.6 billion token actually means, consider human output. An average novel is about 100,000 words, or roughly 130,000 tokens. To break even on your $5,000 hardware purchase purely on text output, you would need your desk setup to generate the equivalent of 12,000 full-length novels. If you are a heavy personal user who prompts an AI continuously, generating 100,000 tokens every single day, it will take you over 450 years of nonstop daily use just to cover the initial hardware expense. 450 years. And that assumes your hardware lasts forever and electricity is entirely free. In reality, Consumer graphics hardware depreciates at roughly 35% per year as new architectures launch. Your $5,000 workstation loses nearly $1,750 in resale value during its first 12 months sitting on your desk. Divide that annual depreciation by 12, and your hardware is quietly burning $145 a month in pure capital decay while sitting completely idle while you sleep. The obvious economic conclusion appears simple. For individual human consumers, running a local AI node is a catastrophic waste of money. So why are rational software engineers, boutique law firms, medical startups, and financial trading desks still buying local hardware by the truckload? Why pay thousands of dollars upfront for an asset that sits idle 95% of the day? Because the human prompt assumption is wrong. The moment you stop treating AI as a conversational assistant for humans and start treating it as an automated internal control point for non-human software processes, the math completely reverses. Consider an autonomous software development pipeline. Modern multi-agent coding frameworks don't wait for a human to type a question. They run continuous background loops. Every time a developer saves a line of code, an internal agent reads the codebase, checks for security bugs, writes test cases, refactors documentation, and queries vector databases. A team of 10 developers running continuous background agents can easily generate 50 million internal Scratchpad tokens every single day. On a cloud API billing model at 30 cents per million tokens, 50 million tokens a day costs $15 a day, or $450 every month. Over a 2-year operational window, that API bill accumulates to $10,800. Put that same team on a single $4,000 local workstation running open weights with $600 in total power consumption over 2 years, and the total cost is $4,600. The local setup saves the company over $6,000 while executing millions of rapid background tasks that no human ever reads directly. The second privilege is regulatory arbitrage and liability protection. If a law firm or healthcare provider sends sensitive client records or patient medical histories to a third-party cloud API, they risk regulatory fines that make a $5,000 hardware rig look like loose pocket change. A single HIPAA or GDPR data compliance violation can trigger statutory penalties reaching hundreds of thousands of dollars. Local AI is not an investment in cheaper tech. It is an insurance policy against regulatory extinction. You are buying structural data isolation. However, even inside this automated workflow, local operators hit a second hidden bottleneck: the physical architecture of silicon memory. When generating text, an AI model cannot process tokens in massive parallel batches for a single user. It must read every single model parameter out of VRAM into the compute cores once for every single token it generates. This means your generation speed is strictly limited not by how fast your GPU can do math, but by memory bandwidth. A standard consumer GPU might offer 1 terabyte per second of memory bandwidth. A top-tier enterprise accelerator offers over 3 terabytes per second. If your memory bandwidth cannot feed parameters to the processor fast enough, your $5,000 workstation stalls, bottlenecked by memory throughput. This is why hardware manufacturers deliberately segment their product lines. NVIDIA intentionally limits VRAM capacity on consumer cards to prevent small businesses from using cheap consumer GPUs instead of $30,000 enterprise chips. Apple, conversely, offered massive unified memory pools on desktop chips, but pairs them with lower memory bandwidth, creating a system that can load huge models cheaply, but generates text at a fraction of enterprise cloud speeds. You're always trading off capital costs, raw memory capacity, and generation speed. So what is the final balance sheet? Let's calculate the real numbers across a typical 3-year hardware lifecycle. If you build a $5,000 local AI rig, pay $100 a month in power and cooling, and account for 60% total hardware depreciation over 36 months, your true cost of ownership is roughly $8,600 over 3 years, or $238 a month. If you are an individual using an AI assistant to write emails, draft essays, or answer general trivia, your cloud API or subscription bill would cost around $20 to $30 a month. By running locally, you are paying a 700% premium for the privilege of owning physical hardware. If, however, you are running high-frequency continuous code loops, processing million-token legal document archives locally, or maintaining total air-gapped privacy for proprietary trade secrets. That $238 a month local cost replaces what would otherwise be $1,200 to $3,000 in monthly cloud API fees and enterprise compliance overhead. Which brings us back to where we started. You thought you were buying a personal supercomputer that would make artificial intelligence free. In reality, you were choosing between two completely different economic games. You didn't buy cheap software. You bought a dedicated private factory floor for non-human token production. If you only feed that factory floor 4 sentences a day, you are paying luxury manufacturing costs for a hobbyist workstation. But if you fill that factory floor with continuous non-human workloads, you stop renting compute from hyperscalers and start capturing the margin yourself. You didn't own the AI, the machine just forced you to become its local utility provider.